Hey class, welcome back to our channel here. We're basically going to be doing lesson 6 today. Lesson 6 I'm going to divide into two parts. So we'll do some of it today and we'll do some of it tomorrow in class. Sorry, day after tomorrow because I'm sending this out the night before. But we'll do some of it on Thursday in class right before we do our review. And if you're watching this lesson and you're still feeling a little bit iffy on lessons 1 to 5, I highly recommend stopping this here, going back and re-solidifying that information. So go back, make sure you do the worksheets, make sure you do the problems, and make sure you hand in your exit tickets because I've been providing feedback. So if you've done all of that and you're ready to move on to lesson 6, we're going to move on. We're basically taking everything we've learned and now we're going to apply it to the real world, right? So word problems are really just taking everything that we know, combining that all together, and trying to solve real world math problems. I'm going to do this in two parts. The first one is we're going to learn how to use different mathematical operations based on the terms and the words that are used in word problems, right? So I'm basically going to show you really how to translate English into math, right? So when we're given a word problem, how do we really answer what the word problem is asking us? And it's kind of like, remember when I told you at the beginning of the term, math is a language. So if you don't know how to speak the language or you don't know how to convert the language, then it'll be very hard for you to understand what to do. So we're going to go over that. The other thing we're going to do is we're going to learn how to translate words into mathematical statements. And then in this lesson, I'm going to go through problems of 2 unknown quantities. And then in the next couple of lessons, I'll go through measurement problems, money problems, and age problems. And I'll make separate videos for all of those so that you don't have to scroll through these and find them. So first things first, what mathematical operations does each word describe? So we're just going to go here and we're going to look at, if I tell you something increases by a number, right? We are adding. If something is divided, we are dividing. If something is doubled, we are multiplying by 2x, right? If something is tripled, we're multiplying by 3, so 3 times something. If we're decreasing something, minus. If we're adding something, we're adding. A sum is also adding. A result is equals. Product is when you multiply two numbers. So I'm just going to write that as an x, but I'll write in brackets multiply. Right? If you are getting less of something or, decreasing, minus. Difference, right? The difference between two terms is also subtract, and the quotient is division. Okay, so that's a little bit of key terms for us to know before we get started. So to translate the following into a mathematical statement, right? This is how we're going to go about this. Since each of the following statements has the word a number or an unknown quantity, we're going to make a let statement. So always make let statements in your models. So you're going to say let any number. So I'm always going to pick x because I just like that. Represent a number. So what I'm going to do is I'm basically going to go in here and replace every time it says a number is increased by 7, I'm going to replace it with x. I know increased by is plus, and then it's increased by 7. Right? A number, so x represents a number, is decreased. So we're going to go back here and find decrease. It's right here. And it's a subtract by 12. The product, so we know that this is going to be multiplied by, of 6 and a number, which we know is x. So I'm going to do the product, so 6 times x. Right? Then I'm going to say the sum, which means you got to add here, of 3 and a number, which is going to be our x. So the sum, so 3 plus x. Right, so we're taking our English and we're just turning it into a language that we can work with here. A number is doubled, so x is doubled, which means you're multiplying by 2. So I'm just going to do x times 2, or I can say 2x. Either one is right. A number is divided by 9, so I know a number is x, and then I'm going to say divided by 9. Okay? So we're going to do a few examples here, right? A number is increased by 12, and the result is 17. What is the number? So the first thing I'm going to do is I'm going to go in and I'm going to do my first step, and I'm going to say I'm going to pick x again. Let x equal a number. I'm not even going to write equal. That might confuse people, so I'm going to say let x represent a number. Right? And I'm going to say if x represents a number, so x is increased, so I know this is plus, by 12, and results, if it's resulting in something, that's another way of saying equals, in 17. And now if I want to solve the number, I just got to solve for x, right? So I'm going to use my balance method. I want to get rid of this 12 here, so I'm going to do x plus 12 minus 12 equals 17 minus 12, right? So I have x is equal to 17 minus 12, which is 5, and that is my answer, right? So do you see how we took just switched over. See how we took a English sentence and changed it into a math sentence in order to solve for the problem? That's what we're trying to do with word problems. And that's why it starts to become very messy if you don't know how to change that over. So that's what I want you to be practicing in these next few questions. So example 2, obviously we start to get a little bit more complicated. So it says 2 times the number decreased by 7 gives a result of 13. So what is the number? So we're looking for some sort of number that when you multiply it by 2, decrease it by 7, results in 13, right? So what I'm going to do is I'm going to say let x represent a number. And this might seem tedious now, but when we start doing multiple equations or multiple variables, it's going to become really important to write this. So I'm going to say let x represent a number. If you want, you can even write in a number. I usually get lazy with shorthand, so I don't, but it's completely up to you. So let x represent a number. So I'm going to say 2 times, so 2 multiplied by a number, which is going to be represented by x, decreased by 7, gives us, so decreased always means we're getting less 7, gives us a result means equal, gives us a result of 13. What is a number? So I'm just going to write this so that it looks a little bit nicer. Equals 13, right? I'm going to do 2x. I want to get this 2x by itself, so I'm going to get rid of the 7 by adding 7. Whatever I do to one side, I have to do to the other, so I'm going to do 13 plus 7, right? And then that's going to give me 20, so I'm going to have 2x equals 13 plus 7, which is 20. And then I'm going to try to get this x by itself right here, right? And in order to do that, I just got to divide this side by 2, because it's 2 times x, so I'm going to divide it by 2. Whatever I do to this side, I must do to the other, so I'm going to divide both sides by 2. X is equal to 10. Okay? And that is my answer. So the number, and you're always going to write it there for a statement, the number is 10. And the 3 dots just represent therefore. So you don't have to actually write out therefore, because I'm a little bit lazy like that. So when you're trying to solve a problem with 2 unknown quantities, right, you need to define each of the quantity in a let statement. So we're going to use those let statements. And remember, like we were using it with one variable, now you're going to have 2. Define them and be like, let x equal something, let y equal something. Then try to define that y variable in the terms of the other variable. So you want all the variables to be just one so that you can plug them into the equation. Because if you have multiple variables, it starts to get messy. Okay? The problem will give you a connection between the 2 variables to help you define the variable. And this seems really, really confusing right now, but let's work through a few problems and it'll make a little bit more sense. So I gave you a list of these instructions, right? Oops, sorry about that. So gave you a list of these great, this is a great tool. So just make sure that you look at it. It will not let me draw a line around it. So I'm just going to draw it in. Okay. So these are great, great thing to bookmark for yourself. Great steps to follow. So when solving word problems, the following format will be expected. This is how you can get 100% on a question. Okay. Let statements, you got to put them in. You got to give me an equation using the information from the word problem. You got to solve the equation showing me all your steps. And then you got to put in a concluding statement. Okay? So we've already done that here. You gave me a let statement, right? We did that. An equation using the information. We did that. We said this is the equation. And then we said solve the equation, right? So I did 1, 2, and then I solved, right? Then I showed all the steps, obviously, and then I put a concluding statement. So I followed all of them here. Okay, we're going to do the same thing up here. So I kind of inadvertently follow them, but just making sure that you do as well. So each statement has two unknowns. Represent both unknowns in terms of x. So we already know that x is going to be a part of this equation. So there are 70 pens and pencils in the basket. So this means that I'm going to say let x equal pens let y equal pencils, right? In this situation, we actually can't define them both as an own variable, but we can just assume that there are 70 pens and pencils in the basket and there's the same amount of them. So we'll say x, number of x, so the number of pencils equal the number of y, right? So we can just say x plus y equals 70. And since the number of x equals the number of y, we can just say x plus x equals 70. X plus x is just 2x equals 70. Okay? It's a little bit more complicated, but as we go on, it'll make more sense. So in this situation, it says the number of t-shirts sold was more than twice the number of sweatshirts. So let's say let x equal t-shirts. Let y equal sweatshirts. And now let's go define this y, right? We're going to change this y into terms of x. So we know that y is equal to, it says the number of t-shirts sold were 3 more than twice the number of sweatshirts. Okay, so y is equal to 3 more, which is plus 3, times twice the number of sweatshirts, times 2 times x plus 3. Okay. So it says the width of a rectangle is 7 centimeters, shorter than its length. So I know that width is equal to 7 centimeters shorter than, which I can say it's less than 7 centimeters, than its length. So I'm going to just say L is the length. We don't know what the length is, minus 7. Right? So if I'm going to always write, sorry, this one was on me. I didn't write the proper form. So I'm going to say let W equal width. Let L equal length. Width is equal to L minus 7. Okay. So let's try and do a measurement problem, just to walk through it. So let's say the width of a rectangle is 7 centimeters shorter than, so if it's 7 centimeters shorter than, we already know it's going to be a minus 7, than the length of a rectangle. The perimeter is 54 centimeters. Determine the dimensions of this rectangle. There's a lot going on here, right? So let's change this into terms that we can understand. Let's start off by defining length and width. So I'm going to make, right off the bat, I'm going to say let x, I don't like x for this. We'll do w and l. Let w equal width. So w will represent width. Rep. I'm just going to write it as rep. Let L represent length. Right? Now we have two kind of things to work with. And if we want, we can just say let P represent perimeter. Let's start off with just figuring out our length and our width. So it says here the width of a rectangle is 7 centimeters shorter than the length. So the width is equal to 7 centimeters less than the length. So width is equal to L minus 7. Right? Now I've defined my width as my, in terms of length. Right? And the perimeter is equal to 54 centimeters. So I know perimeter is equal to length plus width plus length plus width. Or how you can write this is perimeter is equal to 2 times L plus 2 times W, right? So I know right off the bat that I have 2W, and I don't really need to do anything for that. Sorry. I have 2L. I have 2L, and I don't really need to do anything for that. There's nothing else. I just said let L represent length, right? So I don't really need to add anything. I could leave this as 2W, but then I would have two variables still. I went over here and I actually defined W in terms of L. So I can plug that L minus 7 in for my W. Right? I can substitute this. Sub in for W in P equation. Do I know what P is? Yes, because my question tells me what P is. P is 54. So I have 54 is equal to 2L plus 2L minus 7. And now I just need to solve for L. So I'm going to go here and I'm going to say 2L. I'm going to leave it as is. I'm going to distribute this 2L in. Distribute this 2L in. Minus 14 equals to 54. And I'm going to use my balance method to solve for that. First, I'm going to collect like terms. 54 is equal to 4L minus 14. Right? I'm going to isolate that 4L. 4L minus 14 plus 14. Whatever I do here, I got to do here. Plus 14. Right? So I'm going to do 54 plus 14, which will give me 68. And then these two cancel. So I'm left with 68 4L. I want to get rid of the 4, so I'm just going to divide both sides by 4. And I'm left with L is equal to 17. It's asking for the dimensions of the rectangle. I only found L. Have I solved this equation? Nope. Now I want to find W. But I have an equation for W in terms of L. So I can just plug in L. So I have W. W is equal to L minus 7. W is equal to 17 minus 7. And this is a crucial step. A lot of people forget this. And width is equal to 10. So now I have length and width. Therefore, the dimensions are length is equal to 17 centimeters and width is equal to 10 centimeters. You could even draw out this rectangle. Either one would be appropriate. But do you see how we took this question that we seem to be asking? I don't even know what this is asking me right now. And we changed it into a language that we understand. And always make sure that you're answering the question. What's actually required? What is it asking you to solve for? Okay. So we can do another example. We'll do example 5 together. I'm going to upload all the answers to examples 8 and 9. So I'll do example 5 with you. That's a measurement question. Example 6 is a different type of question, so we'll take that one up as well. And then I will do a more complicated example like example 8, and I'll just put up the solutions for 7. Okay? So if you're at home, try this by yourself first, and then just using the same logic we used up here, try to do this by yourself, and then you can come in and take it up with me. Okay, so a rectangle with a perimeter of 76 centimeters has a length that is 8 centimeters greater than its width, right? So just going right off the bat, I'm going to say let W represent our width. We're going to let L represent length, right? And we know the perimeter is 76. So P is equal to 76 centimeters. Okay, we're trying to find the dimension. So we want to find out what is L and what is W. Let's define one of these. Let's define length in terms of width, right? So we know that the length is 8 centimeters greater than the width. So let's determine what the width would be as an equation. So the length is 8 centimeters greater than the width. That means that length is equal to width plus 8, right? And now we have a value for L that we can sub in using width in that equation. So I know my perimeter equation for a perimeter of a rectangle is 2L plus 2W, right? And now I have an L that I can sub in. So I'm going to say P is equal to 76, which is equal to 2W plus 8. I'm just subbing in for this L with this W plus 8 that we figured out was true there, plus 2W, right? And then I'm just going to solve. I'm going to do 2 times W is 2W. 2 times 8 is positive 16 plus 2W. I'm going to go in, collect my like terms, and this just becomes a solving equations problem, right? 76 is equal to 4W plus 16. Want to get that 4W by itself, so I'm going to subtract 16 on both sides, right? So I have 76 over here, and I'm going to minus 16 from it, which will give me 60. Then I am left with 4W. Want to get the W by myself, so I'll divide both sides by 4. 60 divided by 4 is equal to 15. So 15 equals W. Right? So I found the width. So I can go back here and say, okay, I found the width. How can I find the L? Do I have something that gives me what length is in terms of width? Yeah, I know that length is width plus 8. So I'm going to take my length is equal to 15 plus 8. Length is equal to 23. And I'm just going to write my therefore statement. Therefore, the dimensions of this rectangle are 15 centimeters width by 23 centimeters for length. And that's the answer to that question. Right? You follow the steps, you made your let statements. So I'm just going to go back and label our steps. Let statements, we defined it in terms of one variable. We wrote an equation, right? We wrote our equation here, solved our equation here, and then wrote our solutions here. Okay? Gonna go through example 6 with you. It says the sum, so if we have the sum, we know we're adding. We must be adding. Of 3 consecutive numbers is 48. This consecutive numbers will be important. Determine the 3 numbers. So, say let x equal the first number. Let y equal the second number. Let z equal the third number. And let's all kind of define this in terms of x, right? So if x is the first number, right, x is just going to stay the same. So I'm just going to write this in here. So sum, we'll also write sum is equal to first number plus the second number plus the third number, which is equal to x plus y plus z. And that's going to equal 48. That's too many terms that we have there. We can't solve them. What I know is that they're consecutive numbers, which means that if it was like 1, I would have 1 plus 1, which is 2, and then I would have 1 plus 1 plus 1, which is 3, right? 1, 2, 3. So that means that y has to be x plus 1, right? Because it's the number, and the number after that is just plus 1. I know that z has to be x plus 2 because it's 2 spaces over on the number line. So knowing this information, I can go back and plug in x plus 1 for y and x plus 2 for z. And now everything's in the same variable. So I can say 48 is equal to x plus, I'm subbing in y here, x plus 1 plus x plus 2. And now I just got to open up my brackets, simplify, and solve for x. So 48 is equal to x plus 1 plus x plus 2. Let's collect our like terms. We have x, 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 so that's 3x. So 48 is equal to 3x plus 1 plus 2, which is just plus 3. Right, so I have positive 1, add positive 2. That gave me positive 3. So I have 48 is equal to 3x plus 3. Right, I want to get the 3x by itself. So I'm going to get rid of that 3 on that side. So I'm going to 3x plus 3 minus 3. I'm going to minus 3 over here. So I'm left with 48 minus 3, which is going to give me 45. Equals 3x. And then I'm just going to divide both sides by 3 to get the x by itself. The 3 and the 3 will cancel each other out. 45 divided by 3 is equal to x. So I have my first number. If I know what my first number is, right? I know the first number is going to be 15, right? The second number is going to be x plus 1. So I know that y is going to be x plus 1, which is going to be 16, right? And then z is going to be x plus 2. So z is going to be 15 plus 2, which is 17. So if you add 15 plus 16 plus 17, and I'm sure you could have done this in 100 other ways to eventually get to these numbers, but this is the most systematic way to get to it. It will give you 48. So I'm going to write this as a therefore statement. Therefore, the three numbers, I'm going to write 3 consecutive numbers. The 3 consecutive numbers that will give me a sum of 48 are 15, 16, and 17. And I'm just going to go back and say, did I answer the question? Determine the 3 numbers? I did. So I'm done this question. Okay? And a lot of thinking is involved here, and it is a lot of, you have to think about what you're doing. So that's why I'm saying is that this is one of those things that, remember when I tell you with math, everything kind of just ties in. Word problems are a tie in here. That's what we're ending this unit off with. We're ending them off with word problems because they are made to make you think. They're made to make you apply those skills. Okay? So you have one number is twice another number. If you subtract 10 from each number, the sum is 40. What are the numbers? Again, so much happening here. Let's break this down. So let x equal first number. Let just always x equal the first number. Let y equal our second number. So we're only working with 2 numbers here, right? So let y equal our second number. It says one number is twice another number, right? That means that either x or y is twice the other one. So let's just say y is twice the amount of x. So we're going to say y is 2 times x. We've kind of defined our variable. If you subtract 10 from each number, the sum is 40. So if I subtract 10 from x, right? And I subtract 10 from y, so I'm going to do x minus 10 plus, right, because the sum is 40, plus y minus 10, because I'm subtracting from each number. Our sum, so everything added together, is 40. Right? So if I subtract 10 from x and I subtract 10 from y, then I add them together, I'm going to get 40, is what this is basically saying. I have 2 variables, can't work with that, but I can go sub my y with 2x now. So I can say x minus 10 plus 2x, always put it in brackets when you're subbing, minus 10 equals 40. And now I have 1 variable and I can work with that, right? So I have x minus 10, and that's just in a bracket, so I can just open it up like that, plus 2x minus 10 equals 40. Gonna go in here, collect my like terms. I have x and I have a 2x, so I'm gonna say 3x. Then I have minus x, and I have a minus 10, minus 10 minus 10. Negative 10 minus 10 is just going to be minus 20, which is going to give me 40. And now I just got to isolate for that 3x, so I'm going to get rid of that negative 20. Negative 20, got to add 20. Other side, 40, got to add the 20. 40 plus 20 is going to give us 60. On this side, it's just going to give us 0, so we won't write it in. You're going to do 3x, right? I want to get the x by itself. Got to get rid of the 3. 3 and the 3 cancel each other out. X is equal to 60 divided by 3, which is going to give us 20. So one number is x, which is 20. So therefore, the first number is 20. How can we find the second number? Simple. We just plug it in. We say the second number is y, and y is equal to 2 times the first number, so it's y equals 2x, so y equals 2 times 20, so y equals 40, right? So you're going to put that in. So the first number is 20, the second is 40, and that makes sense, because if I did 20 minus 10, right, I would be left with 10, and then if I did 40 minus 10, I would be left with 30. 10 plus 30 will give me 40, right? So this is just a way to solve these problems when they're given to you. It's a way to turn the English into math. And it's also, I know it seems very tedious right now. You're like, why are you doing this? You could have just done that. You could have been like in your head. You could have figured it out. And yeah, you can. But we're teaching you how to solve these word problems now, because when you move on into grade 10 and you start functions, even when you move on to linear equations in grade 9, when you move on to grade 11, when you move on to more complex math, right, knowing how to do it this way is actually more beneficial to you. And when you're applying these into the real world, when you're actually trying to solve problems, this is the most efficient way to do it. All right? So that's example 8. I will post a solution to example 7 on D2L. I'm going to let you try example 7 and example 9 by yourself. And then tomorrow we will take up money problems, and we will take up age problems. And that's it. And then we're done this unit. So thank you for tuning in. I'll post those solutions tomorrow. All right. See you tomorrow.